Hello viewers, welcome to this morning session on the lecture on a special topic which is nothing but communication system, satellite communication and optical fibers. A special thanks for the people who are joining me during this interactive class, and also I welcome all the students and all the viewers who are going to watch this program. Let me try to do some justice for this topic, which is there for diploma. For some branches, it is there for first sem, and some of you must be preparing for your second sem as well. So my topic for today is communication. Communication. Let me explain what is that communication. What I'm doing now is a communication. I am in a studio in Bangalore, and you are in so many other places watching my program live. I am giving a lecture on a particular topic, and whatever is there in my mind, whatever I have learned, and whatever it is there according to the plan, I want to transfer it to the viewers. Many of the students don't sleep, try to watch, thereby you will complete that communication. Whatever I want to express, that has to be carried, it has to be propagated, and has to reach the other end. Thereby, communication requires a source and a receiver. So I am a source now, right down. I am a source, and you're all watching my program, and you're all receivers. That is the beauty of communication. And in communication, the latest method, even in classrooms also, during my lecture also, some of you must be communicating in one or the other means. There are different methods of communication. Even animals also do communicate with each other. Birds also communicate, and we communicate from one place to another place, from one person to another person, directly or indirectly. Now, my today's lecture is something on communication with the help of some electronic devices, wherein which it is not direct, not face-to-face, but it appears to be face-to-face. In fact, there are so many other things happening in between. So, in order to do this, let me take up the first meaning, communication system. This is my today's topic. And if at all you want to understand what is communication system, you require communication, the definition of communication. What is the definition of communication? It is the field of study. This is something connected to electronic communication, the telecommunication. In other words, it is the field of study concerned with the transmission of information through a series of processes from one point to another. Communication, it is a field of study concerned with the transmission of information. I have some information. I want to pass it on to you students. Thereby you can understand it. You can keep them in your memory, and you can later on apply during your examination. So the communication, it is a transmission of information through a series of processes from one point to another point. I am communicating here with you and other people. So what are the major things that are required? So the basic elements in communication system, it is a system. When I say system, you think of your body systems. It may be a respiratory system, or it may be a digestive system, and so on and so forth, or nervous system. So there are so many systems you are already familiar with. But now we are talking about not biological system, but it is the communication system. So what are the basic quantities or the basic items, or what is the basic principle that is involved? All those things we are going to study now. So in basic elements of communication system, first to begin with, we have a source. When I say source, it may be a person, or it may be anything which has got certain information that has to be passed on to some other place. Thereby, we have a receiving point, in other words, in a user. So now I can say I am the source of this today's lecture, and you are the users who are going to make use of my lecture. So in order to do that, we require there is some gap, and how that gap is utilized, in what way it is possible means I can introduce a system which we call it as a communication system. So instead of directly communicating, I did not come to your college, I'm not taking the lecture inside the classroom, whereas I'm taking the lecture elsewhere and you are watching my program. Thereby, I'm having some other system in between me and you. So this is what we call it as communication system. So what are the major parts of a communication system? A communication system mainly consists of a transmitter, then we have a channel and a receiver. So in between the source, in between me and you, we have these three major points, namely transmitter, channel, and receiver. So transmitter, there is a device. We'll discuss about them one by one. So whatever the information that is given from the source is transmitted, or it is passed on to the transmitter. In turn, the transmitter passes the information through the channel, and from the channel, the receiver receives the message, the information, and finally, it will direct to the user like you. And in between this, we have some unwanted elements, unwanted information that may be coming into our way. It is something like having a good habit in a person. Here and there are plenty of chances wherein which other peoples will come and spoil our mood or our habits or our name. And in the same way, there are some informations, the false information, the wrong informations, which is not the correct one, which is unwanted. We call it as the noise. And that also may be joining in between the transmitter and the receiver. So basically, now leave alone the source and the information. Let us take up only the communication system. In the communication system, mainly we have a transmitter, a channel, and a receiver. Of course, there may be some sources of noise which may be within the system. It may be within the system, or sometimes it may happen or it may come from outside the system also. So what are the basic terminologies that we are going to, that we have to understand in this particular chapter, which is nothing but communication or in communication system? So what is the first term? It is terminology, because communication system, we have volumes of books. We are not going to study everything. We will be restricting ourselves for the syllabus for the diploma students, diploma level. Thereby, you can understand them only the required material, the portion of the material of communication system. It will be studied even under a master degree or at the research level. We are not going to that level. We are going to think of the basic terminologies, the important terminologies which one has to understand. So when we are in the world of communication, we have developed so much in communication, but without understanding certain terminologies, it is of no use. No doubt, we are watching TV, that is, the application of the communication system. We have internet, that is the, advantage of the application of communication system. With all this, if you don't know the basic definition, it is of no use. Just operating the machine, you'll also become a machine. So as a science student, let us try to understand some of the basic terminologies that we are going to use. The first one, we call it as transducer. Transducer. So whenever I want to talk or address a larger mob or a gathering, we make use of a mic. Simple example. I cannot talk to the entire crowd. So I make use of a mic, And no doubt there will be amplification circuit, and there will be a speaker and other things. So what is the function of the mic? Mic converts my sound energy into a different form of energy. Generally, we say it is electrical energy. That is why if there is no power supply, we cannot operate the sound system. That means there is some relationship between my sound, whatever the sound which I am producing, and it has to be amplified. In between, there is what we call it as transfer of energy. The sound energy is converted to electrical energy. And mic, in my example, the present example, I can say it is a transducer. So in general, what do you understand by the term transducer? Any device which converts one form of energy into another form is known as, or it is called, a transducer. So it can convert, in some cases, it may convert voice. Now I'm talking in front of you. My voice has been converted and finally it is reaching you. So there is a transducer which converts my voice. Not only that, my image you are able to see right now, live program, it is only because of a transducer. You can think of which is the transducer. Unfortunately, I'm unable to hear your voice, but some of you must be joining me. You'll be participating or you'll be coordinating with me. So it is the device. Later on, you can tell me what is the device. I'll keep this as a question for you. You answer this question. My image is reaching you. So what is the transducer? Not the point, not the question, and give me the answer at the end. Because in the previous lectures, many of the students, they don't interact. I don't know why. I don't know whether they are finding fault with my language or pronunciation or the communication. I don't know what is the mistake. Anyway, today make it a point to communicate with me. I've given you a question. What is the transducer which is used? Note down the point. What is the transducer which is now in use right now, which converts my image and finally it makes you to reach the audience? So transducer, any device which converts one form of energy to another form. If that is the case, you can ask me a question. An iron box also converts one form of energy to another form. Their electrical energy is converted to heat energy. Can I call an iron box as a transducer? No, technically speaking, it may be, but in communication, we say no, because it is nothing, it is not playing any role in the process of communication. Therefore, iron box is not, or a heater for that matter, it is not a transducer. Whereas in communication, one form of energy, where exactly it is possible, we'll discuss afterwards. So at some place, one form of energy has to be converted to another form. Okay. So what is the next basic definition? Signal. So signal means some information after being converted. So my voice is there, and my voice is not traveling to the places wherever you are staying, but my voice has been converted in the form of a signal. In the form of a signal. When I say signal, it is nothing but a wave. Signal. My voice has been converted into a signal, and now it is ready for transmission. So whatever the item which is now produced after the transducer, we call it as a signal. And there are two types of signals. Just let me finish off this. So what is a signal? Source of information converted into electrical form using a transducer which is suitable for transmission. If it is not suitable for transmission, you would not have seen my image, nor you will be hearing my voice. So it is properly modified, properly converted. Thereby, I say there is a signal. So what you are reaching and what I'm sending now from this studio, it is only a signal. It is not me who is sending, it is some other. The system is sending. My voice and my image has been converted into a proper signal which is appropriate, suitable for transmission. Then it can reach the other end. So signal, it is a source of information converted into electrical form using transducer, which is suitable for transmission, is known as a signal. It may be either analog or digital. Of course, analog signal and analog communication, digital communication is once again a broad chapter altogether. But when I say analog, it is a continuous wave. The information or the signal is propagated as a continuous wave. So what is a continuous wave? The transverse waves, whatever you have considered. So here there is a variation in electrical signal or magnetic signal, we can say. In general, let us take up only one, electrical signal. The electrical signal, there is a fluctuation of electrical signal. In the previous lectures, I have demonstrated what is known as electromagnetic waves. So whatever the waves which are used for communication purpose, they are nothing but electromagnetic waves. So whatever the signal which I am producing, or whatever the signal that has been formed using a transducer, it may be a continuous wave like this, or it may be a discrete wave. It may be like this. A discrete is not continuous. That means this gap is open, we can say. Here, the value, we say it is equal to 1, and here the value is equal to 0. In other words, there is a maximum value and minimum value. But here also there is a maximum value and a minimum value. There is a continuous variation. There is no, what do you call it as, any gap at all. The wave increases, decreases slowly, then increases in the negative direction, increases in the positive direction, and so on. There is a continuity, whereas here it is discontinuity. That means up to this point it is maximum. All of a sudden there is a rapid fall, decreases suddenly, and there is a 0 value for certain interval of time. Again it shoots up, decreases, shoots up, and so on. That is why we call it as a discrete signal. A source of information converted into electrical form using transducer, which is suitable for transmission, is known as signal. It may be either analog or digital. We call this as analog signal. Whereas this is termed as digital signal. So let us not bother about the entire process, what is happening, how the signals are formed, what are the electronic components, all those things. That is not important for us. So only the terminologies. Next is, in analog signal, as I already mentioned, there will be a variation of voltage or current continuously. Whenever there is a continuous variation in the signal, or the signal containing the signal showing a continuous variation in either voltage or current, such as a type of signal, we call it as analog signal. On the other hand, if you have in digital signal, variation is discrete. It is not a continuous, it is not a sinusoidal wave. Here it is a form of a square wave. Sometimes we call it as a square wave, and in some cases we may find the sawtoothed wave and so on. So let us not go in detail. Let me not disturb you. So we have generally signals may be either analog or it may be digital. Analog signal is a continuous signal. Digital is a discrete signal. So analog, they find some value maybe, so this, here it is a variation of a voltage, or it may be current. It is plotted in this direction. Whereas here we find the phase, we call, this is 0, corresponds to angles, 0, pi by 2, pi value, 3 pi by 2, 2 pi, and so on. So in other words, 0 degree, 90 degree, 180 degree, 270 degree, 360, and so on. It will continue for a longer range. What is the next point that we are going to discuss? So in digital signal, we have minimum value and maximum value. Minimum value, I told it is 0. Maximum value, it may be 1. That means the entire signal under digital signal have either 0 or 1. It is something like a switch. Either the switch can be in the off position or it may be in the on position. We cannot keep a switch half on and half on. Sorry, half on and half off position. That means you cannot break the circuit half to and half an amount. It may be either closed or it may be open. Only two choices. In discrete, only two possibilities. Whereas in continuous signal, there may be small fluctuations, continuous signals, continuous values. It is something like I can say your age, it is continuous. Your age is continuous right from your childhood. We say, well, 1 day child. That means the next day after your birth, we call it as 1 day. It may be 1 minute, or it may be 1 month, or it may be 6 months, or it may be 1 hour, or it may be 1 year or 2 years, 50 years, golden jubilee, silver jubilees. There are so many other jubilees and centenary. So your age is continuous value. Whereas the amount, whatever you are paying, 100 rupees, in between that, if there is any currency, we say 100, 200, 300, then we say it is a discrete value. And even in case of atomic structure, we say there is a discrete value of energy. It is not continuous form of energy or continuous values of energy. So 1 is used to represent a high level in electronics. People, they study. 0 corresponds to low level. It is only the information in the other way. 0 means it is low level. 1 means maximum or higher level. Only two possibilities. We don't have any value between 1 and 0. We don't find values like 0.07 or 0.5 or 0.57 or 0.9. Such values are not possible at all. So either it must be 0 or it is 1. 0 corresponds to lower level and 1 corresponds to higher level. Already I told you noise. Most of the times, lectures generally they get annoyed whenever we find some noise. That is not needed at all. The students are made to speak. Speaking is different from making noise. Making noise, nobody can understand. Only some sound will be there and it will spoil the entire situation, the entire mood of the lectures, because sometimes you may get annoyed and sometimes 1 or 2 students may be penalized and they'll be sent out. It is only to keep the classroom under control. That means the noise is an unwanted, undesired signal. Some signals will join the main signal, which is unwanted. Unwanted electrical signals that interferes. That means they will mix up with the main signal. Main signal is what is required, but along with that, some unwanted signals also can join. It will be superposed, overlapped on the main signal with the transmission signal is known as noise. So unwanted signals superposed on the main signal, the important signal that has to be communicated, the information that has to be communicated, that is known as noise. So the unwanted. So noise means it is an unwanted one. Don't make noise means don't create any unwanted sound in the class, or it may be in the society or elsewhere. It may be produced inside the system or from outside. In the beginning itself, I told you, sometimes the system itself, if you don't design the system properly, there may be some unwanted signals which are produced. That is what we call it as the signal, the noise, which is due to the system itself. The imperfect designing, we can say, because of the imperfect designing, improper designing, there may be some signals which are unwanted that may be within the system, and sometimes there may be other vibrations or other sources which are producing some it is something like some viruses in your computers which is not required. So viruses, it is once again some sort of information which will be mixed with the system, and thereby sometimes it will spoil the system itself. So noise, unwanted electrical signal that interferes with transmission signal is known as noise. It may be is missing there. It may be produced inside the system or from outside. So Now we are familiar with the three terminologies. So what are the other terminologies? Transmitter. So transmitter, where it is present. Now in this studio, I am in a studio there. There is some signal, and next to that, or maybe in the terrace, there we find some devices which will transmit the signal from one place to another place. When it is possible, only when it is converted, only when it is changed to some other form. My voice directly cannot be reaching you, cannot be sent directly to such a far off places. There is a device, transducer is there, which converts, and the transducer in turn, there will be one more process which we call it as modulation. So modulation means it is overlapping the main signal with another type of waves, which we call them as carrier waves. It is something like I cannot travel a very large distance. So instead of traveling to a larger distance on my own effort, I may sit in some vehicle. Sometimes I can board a train or I can sit in a car. Thereby, the car will be taking me to some other place of my destiny, the place I want to reach. But I will be quite comfortable. I will be relaxed. At the same time, I will not feel tired. And in the same way, the signal, it cannot cover to a larger distance. The signal is superposed on another type of wave, which we call it as carrier wave. Carrier waves are generally microwaves or radio waves. So once they are superposed, we call it as a modulated wave. So what is a modulation? It is a phenomenon, a process wherein which the signal, the information after coming out of the transducer is made to mix up or overlap on a carrier wave, and that has to be propagated, that has to be sent, something like firing a bullet. The gun is used to fire a bullet, and in the same way, the information or the signal along with the carrier wave has to be propagated, has to be thrown out, has to be sent out, and such an information, such a type of device which is responsible for it is known as transmitter. So what is a transmitter? The purpose of transmitter is it processes the incoming signal. There will be a transmitter, a signal will be sent to the transmitter. The transmitter, it will collect the signal, and its main purpose is to make it suitable for transmission through the channel. So it will convert, it will modify so that it will be ready for transmission. So transmitter, the main purpose is to transmit. Before transmission, it will design, it will appropriately correct it, or it will make it into a proper shape, proper condition, then only it will be ready for the transmission. So transmitter, it processes the incoming signal so as to make it suitable for transmission of that message or the information through the signal, through the channel. So what is a channel? Channel. It is channelize, means make a way, channelize. So whenever information is given, if there is no proper channel, sometimes some people, they get some appointment, sorry to say, nowadays sometimes it is so happens, sometimes deserving candidates, they may not get chances to get into the job of their choice. Main reason is they don't get proper channel, or sometimes they may not apply in the proper channel. It can be taken in two senses. So whenever you apply anything and you go in a proper channel, you can achieve something. Sometimes the people, they make use of shortcuts or wrong routes or bypass routes through some other people, some influence or some money and other things. That is another channel for some other people. So the choice is yours. Try to go in the right path. Try to be honest. Try to be direct. Okay, don't go in the indirect way. Even in your examination also, make use of direct channels. So channel, it is a medium. through which the modulated waves are propagated. So modulation, I told you, it is a mixing up of a signal and the carrier wave. Along with that, we don't find any difference between the two waves. It is something like when you are sitting in a train, you cannot say the train moves faster than you. You are seated in the train and you will be moving at the same velocity as that of the train. And in the same way, the signal also will be carried very similar to the velocity or exactly equal to the velocity of light. One more question for you. What is the velocity of light? You answer me at the end. In other words, what will be the velocity of the transmitted wave from the transmitter? Not the point. What is the velocity with which a transmitted wave can propagate? Already the information is clear. Already in the previous lecture also I have given you. So you tell me what will be the velocity. Will it be equal to the velocity of train or an aeroplane or a rocket or whatever it is? You just mention me. So channel, it is the medium through which the modulated waves are propagated. So what are the possibilities? Sometimes there may be air, and all this electromagnetic radiations, they don't depend upon any medium. That means whether air is there or not, electromagnetic radiations can propagate. We call them as non-mechanical waves. Already I mentioned in the previous lecture. So these waves need not require a medium, but we say they pass through the medium. They are passing through. Though it is not necessary, there is a way, and the waves or the signal has to propagate, or the transmission is possible through a medium. That medium, we call it as a channel. It may be a vacuum, because electromagnetic radiation can pass through even vacuum and even through air also. So channel, it can be either air or vacuum, or I'm going to start something on optical fibers also. So sometimes information will be passed on, not in air, not through vacuum, sometimes through some medium, which we call it as optical fiber, that I'll take up after some time. What is amplification? If at all you want to carry, or if at all you want to travel, especially during examination, your parents will take care of you properly and they will nourish you so that you will not faint in the examination hall, because that will be utter failure. Sometimes the student, they will keep on studying and they'll forget. You may ask me the question, why we don't get hungry during examination? Mainly it is because your brain is concentrating only on the studies. It will not allow other systems to function properly. It is least bothered about other systems. So your brain is mainly, that is why we say it is tensed, and sometimes you will not know what is happening there during that time. So before going to your examination, you will be nourished. Thereby, you will have sufficient strength to reach the examination hall and to write the examination properly. And in the same way, before transmitting the waves, in order to boost up, in order to give the sufficient energy to cover a larger distance, the waves are boosted, what we call it as amplified. So that phenomenon of increasing the energy of the transmitted wave is called amplification. So amplification, what is amplification? It is defined as the process of increasing the energy of the signal. So the signal is propagated along with the carrier wave. When I say signal, no doubt it is now joined carrier wave. Where is the signal? So whenever you are communicating with your parents, you will say, where are you? If you are, for example, if you are sitting in a train, you will say, I've reached this place, Mysore, India, or some other place. You will not say that train is at that point. You will not say, it will not mention train, because they know pretty well that you are in the train. So when the train goes to some place, you're also going along the train. Therefore, we will be concentrating mainly on the signal. So the signal has to be given some sufficient amount of energy in order to cover up the required distance. For that, there is a process which is required, which is known as amplification. There will be some electronic devices, they will take care of everything. Amplification, amplifiers are there, they will make use of the waves, they'll collect the signal, and they will amplify that, and thereby it will be taken to other regions. So while discussing this amplification, we have to think of one more definition, which we call it as attenuation. So initially, when let us say the wave is having a larger amplitude, as it goes, I'm shortening the distance. It is not necessary that it will get damped. We call it as a damping effect. So the wave amplitude is known as amplitude is decreasing time to time. As a result, finally the amplitude will become very small. It is something like calling out as some person within a room. It is easy. But at the same time, if you want to call out a person without any mic or anything, if you call out a person who is very far off, it is not possible because the waves, they get damped. That means the amplitude decreases, and finally it will become so small it cannot be heard. And in the same way, the light also, the torch that we are using cannot be used for miles together because the intensity decreases. So amplitude and intensity, they are directly related. Intensity, we say, is proportional to the amplitude, square of the amplitude. Intensity, brightness, the strength, in other words. So as the amplitude increases, indirectly we are increasing the intensity, the strength of the signal can be increased. So amplification, it is defined as the process of increasing the the strength of the signal. What is a range? Range. Before coming to the definition of range for communication, let me think of range. You may have a shot put, you can throw it, it may fall few feet away from you, and some other person can throw it farther distance. In other words, the distance from which it is thrown may be higher. There we say your range may be higher or lower than the other person. So what is that? Range. When I say range in projectile motion in physics, we say when a particle is thrown from this point, it traces a parabolic path and it reaches the ground at some other point. So the horizontal distance, the maximum distance for any particle, all particles, whether it is javelin or discus throw or shot put or whatever, even for example a stone, when it is thrown in Earth's gravity, always it traces a parabolic path, which we call it as a projectile, and there is a projectile motion. The maximum distance covered by the particle, the horizontal maximum distance covered by the particle, we call it as range. That is for a particle. In the same way, electromagnetic radiation, whatever the transmission that we are going to propagate, cannot go to any extent, any distance as possible. There is some limitation. So the maximum distance, it is defined as the maximum distance between the source and the destination up to which a signal can be received sufficiently larger. First, before going to this, let me say, when I'm talking to a person, when he is closer by, he can hear me properly. If he is slightly away, he can hear to some extent. And as he goes away, he cannot hear anything. So what is the maximum distance up to which my voice can be reached? My voice can be heard by a person. That distance, at the same time, it should not be a deaf person. So if his ears are properly, if it is in the proper condition, he can hear it, provided he is within the range. If he is going beyond the range, it cannot be heard. And most of the times we find out of coverage area. That means the signal is not heard, means, or not collected or received, means you're somewhere, you're not within the range. So you have to come back to the range, only then we can hear we can receive the signal. So what is the range? It is defined as the maximum distance between the source and the destination. Destination means the point where it is going to reach. So now I can say you are within my range. All of you are watching the program, you are within the range. I suppose you are hearing my voice, you are seeing my image. That means my signal, my information is reaching you, means you are within within the range. If you are away from the range, you would not have received the signal. What is a bandwidth? So whenever the transmitter transmits certain frequency, it cannot send only a particular frequency. It cannot stick on to a particular frequency. On the other hand, we say there is a width, there is a range of frequency. There is a frequency, the main frequency is there, and slightly more than that or slightly less than that. It is something like buying an object. Let us say you are buying a watch or a dress. We say more or less, more or less. That means it may be slightly less than that or slightly more than that. So we fix up the range. Or sometimes when you go to buy some saris or any jewels in a shop, first of all, they will ask you what is the range that is required. You cannot say exactly for 10,000. No, it is not like that. Or you cannot say it is exactly 1 lakh. It may be slightly more than that, or it may be slightly less than that. So around that value. So 1 lakh means it may be around, not 1 or 2 rupees. It may be 10,000 or 20,000 rupees this way or that way. That is plus or minus 10,000 or 20,000. Altogether, if it is plus or minus 10,000, 10,000 to the right, 10,000 to the left, then we say it is 20,000 is the range. And in the same way, sorry, the 20,000 is the width variation. And in the same way, in the frequency also, we have some range. Main frequency is there on either side, slightly more than that frequency and slightly less than that frequency. Put together will give you the bandwidth. So what is bandwidth? It is a range of frequency over which an equipment operates properly. All equipments cannot operate for all frequencies. No, it is not like that. Some equipments can vibrate only for certain range of frequency. Then we call that range of frequency as bandwidth. It may be higher or it may be lower also. So what is modulation? Already I explained what is modulation. It is a process of superposition, superposing a low frequency signal. So the signal frequency will be generally low and it will be mixed up or superposed with a higher frequency. Superposition, that also you must have studied in waves. There is a superposition of waves, means one wave falls exactly over another wave. Sorry, falling or overlapping over another wave. That is called a superposition. The crest of one wave falls over the crest of another wave. Then there is a construct interference. When the crest of one wave falls over the trough of another wave, there is a distinct interference. Everything you might have studied under superposition of wave while studying this stationary waves. And in the same way, the new pattern, I'll give you a small diagram afterwards, how this modulated wave will look like. So modulation, there are different types of modulation. There may be amplitude modulation, or there may be a frequency modulation. Thereby we say AM waves or AM signal, amplitude modulation signal, or FM radios. Nowadays it's quite common. There we say it is frequency modulated. That means frequency of one wave and frequency of another wave. Frequency of the signal and the frequency of the carrier wave, when they are mixed up, it will be entirely a new frequency that will be carried and it will be received at the other end. So after modulation, you should know what is known as receiver also. What is a receiver? It is not there in the slide. So receiver, already I told you about the three major parts. One is transmitter, then we have channel, then it is a receiver. You are transmitted and there is a channel, and if there is no receiver or the receiver is out of order, you would not have received my program. So receiver also should be in a good condition. So the receiver, it once again demodulates. That means initially it was mixed up. The signal and the carrier waves, they were mixed up and they propagate. And at the receiver, there is one important process which takes place, wherein which it changes or it splits the signal from the carrier wave. And only then, again, it has to be amplified, and it has to be sent to the person or the what do you call it, as the persons or the destiny, we can say. So transmitter transmits the energy and the receiver receives the same energy. While transmitting, there is a modulation. There is during the receiving end or at the receiving end, there is what we call it as demodulation. So here we have a spectrum. I don't know how far you can see this. So different ranges. Of course, it is only a small, just to give you a small idea how the bandwidth changes, what are the zones at which the bandwidth can be utilized. So here we have, let me start from the first one. So this is in terms of wavelength, and here it is in terms of frequency. In electromagnetic spectrum also I mentioned in detail. So as the wavelength increases, frequency decreases. So here it is in the order of increasing the, wavelength is, first is 10 to the power 10 to the power 3, 10 to the power 2, 10 to the power 1, 1, 10 to the power minus. That means it is in the decreasing order. And here we have that carrier waves. What are the carrier waves? Let me give this example. Or microwaves. Microwaves, they fall in this region. And transmission station, what is the range? Range means we can say 10 to the power 3 to 10 to the power 2 in terms of meter. 10 to the power 2, it is 100 and 100 meters. Here I can say it is 1 kilometer, 1 kilometer. So some waves, they fall under this range. It is only to just give you an idea how the signals they fall and how the signals, or what is the range at which it is operated. So here we have a microwave oven. It operates at certain signal. Okay, let me skip this. So what is the bandwidth? Next is, what is the bandwidth? It is the range of frequency over which an equipment operates properly. Modulation, it is the process of superposing a low frequency signal on high frequency wave before transmission. So this is a simple sketch showing the modulated waves. So here we have a frequency and this is another frequency. So the two frequencies, they are mixed up and a new form of wave is found, which we call it as modulated wave. This is the wave being transmitted from the transmitter. So only signal alone is not propagated, or the carrier wave alone is not propagated. Carrier wave along with signal, or the signal overlapped over carrier waves, they will be propagated, and such a type of superposed wave, we call it as modulated wave. So what is demodulation? This happens in case of a receiver. So it splits up. It is a process of regaining. So you are getting back the original signal. Otherwise, if it is mixed with radio waves, so whenever you are standing in an open field, you are surrounded by so many electromagnetic radiations or radio waves. But without any receiving device, without radio or without TV or without your mobile, you will not be able to receive any signal. It is only because there is no receiver in your hand. And the radio waves, they cannot be detected or it cannot be seen with our naked eyes. It cannot be heard nor it can be seen. Thereby, we require the signal which is in the original form. And in order to do that, the signal has to be separated. It has to be separated from the carrier wave. Only then it can be sent to the receiver, or it can be caught by or collected by the person who is going to receive the signal, or the destiny. So demodulation, it is a process of regaining the original information from the modulated wave at the receiver. So modulation takes place in the transmitter, whereas demodulation takes place at the receiver. Now there is a special type of satellite communication. Sometimes direct communication, direct with the help of the transmitters, it can cover up a shorter distance. But if at all you want to cover up the entire globe, whatever the communication which takes place throughout the globe, for example, if some cricket match is going on someplace, and if only the people who are in the stadium are allowed to see, what will be the situation? Only few people will be gifted for that. But at the same time, other people also, they are interested, equally interested, but they cannot go to that place. At the same time, they can watch such programs worldwide simultaneously. It is not that the people will be in the room watching it. It is something like some of you who are seated in the interactive class. It doesn't mean that you are allowed to see. In EduSat, there was some other program wherein which only selected colleges, they were allowed to see the program on live, and sometimes it will be it will be recorded and it will be relayed later on. But now it is a relay, a direct relay. It is going on not only for the students who are allotted, even others also. People from other countries also, they can be watching my program, provided they know my lecture is there today. So it is only because of a special type of communication with the help of satellites. So it is not a natural satellite. Some artificial satellites are launched by one or the other method, and they will be generally geostationary, and they will be at some altitudes. The satellites, generally, they should not be very close to it, because whatever the signal that is received, and it has to be transmitted. So if this is the Earth's surface, and if the satellite is very close to it, it can have a range up to a certain point. It cannot go beyond this angle. The information cannot be reached, or it cannot spread beyond certain angle. At the same time, if you go to this, if you keep on increasing the height, then you can increase with a smaller angle, we can cover up the entire area. And likewise, if you have Earth, if you think of Earth, by suitably using 3 satellites, major satellites, we can cover up the entire portion. So this can take care of, if I say A, B, and C. A is one satellite, B is another satellite, C is the third satellite. So this can cover up this entire portion very easily. And similarly, this can cover up the entire portion easily. That means with the help of 3 major satellites launched at certain orbit is of the order of, according to the calculations, which is once again not very much important for us. Most of the satellites, they are launched at the altitude of 36,000 above the Earth's surface. And you are getting the information from such a large distance within no time. It is only because of the phenomenon which we call it as synchronization. The time will be properly adjusted. There should not be much delay of sending the information and getting back. For example, if I'm sending the information from this point, it can reach this satellite, and in turn, it will be sent back to the Earth, or sometimes it can be detected directly. It can be sent to another satellite also. It will cover up the rest of the region. It is something like having different agents who are working out simultaneously. If I say something, if I have a number of agents, if I pass on the message, my agents will be doing my work elsewhere. In the same way, satellites, once it is communicated to one satellite, it will pass on the message to other satellites, and within no time, it will be communicated very easily. So for this, we require satellite communication. So simple diagram wherein which there is a satellite which receives the information from one end, and it transmits to another end. And the satellites, they will not be in one place. They will not be in one place. Instead, they will be revolving around the Earth. But for a person who is observing the satellite, for him, it will look like they are stationary. And such a type of arrangement or launching of satellites, such a type of satellites, they are called geostationary satellite. That means Earth is rotating about its axis, and along with the Earth, the satellite, they have to revolve around the Earth. So to say, if Earth takes 24 hours to complete one rotation, the satellites, they'll take 24 hours to complete one revolution, because they are at a higher altitude and they have to go with a larger speed, and thereby, what are the information that will be communicated, it will be perfect, and which will not have any defect at all. So this is another diagram of satellites. Now we can say that only few satellites are there. But now it is very similar to the Bangalore place, wherein just before 5 years we can see the condition, and now what is the present condition? Everywhere we find the traffic jam. And in the same way, not only on the road, not only in Bangalore, even in outer space also, there are plenty of satellites being launched by different countries for their prestige, for their name, for their requirement. So more and more satellites are being launched, and more um, nations, they are making use of their own satellites for their own purpose. And thereby, we say that outer space is getting crowded. No doubt, it may take a very small volume, but it is getting crowded. And after some time, we may find some traffic jam in the space also. So definition, what is the satellite communication? The communication between the transmitter and the receiver. So whenever I talk about communication, we say there is a transmitter and a receiver. In between that, we introduce one more device, which we call it as a satellite. Satellite, it is launched, it is at a higher altitude, so the information will be passed on to the satellite, and in turn, it will be sent to another receiver. That means instead of making use of the information to propagate from the transmitter to the receiver, we are making use of a via media, which is nothing but a satellite. Through the satellite, the information is transmitted. Such a type of transmission is known as satellite communication. So communication between the transmitter and the receiver through the satellite is known as satellite communication. Communication satellites are geostationary. I told you about the geostationary, and they are orbiting around the Earth at an altitude about 36,000 kilometers away from the surface of the Earth. Advantages of satellite communication. They are used in mobile communication. Those days we have to make use of only telephones, which were stationary, which were there on the table. We cannot move about. You have to, when the telephone bell rings, you have to come inside the room and receive it. But nowadays, we have to, whenever it rings, you have to go away from the room. That is only because of the signals are not available inside the room. It is altogether different type of communication. The mobile communication, sometimes we may not receive the signal properly, but satellite communication helps us in mobile communication. It is a direct broadcast service. It will not take much time, as I told you in telecasting so many other programs like live programs. The time taken will be very small, and it is direct telecast. It is used in direct broadcast services. A single relay station. If you make use of a single relay station, we can cover up very large area on the Earth's surface. These are the advantages. And what are the charges? Nowadays we find 1 rupee. With the help of 1 rupee, we can communicate over entire India. So it is only because it is a charge independent or the distance independent. The charges are independent of the distance, and it is economical. And it is easy to install new circuits. Disadvantages of satellites. Initial cost, because once the satellites are launched, then it becomes easier. Before that, it is costlier. And the signals are open. That means there is no secrecy. Security purpose is lacking there. There is a delay in the response. Sometimes you might have watched in TV programs of the thing. Some person will be interacting and they will answer few seconds after that. It is because of the delay. It is happening there. And orbits are getting crowded. This is one more disadvantage. So these are some of the disadvantages of satellite communication. In the examination, if they are asking you to give the different sorts of different types of disadvantages. Number one, initial cost will be more. Signal is open to all. There is a delay in the response, and the orbits are getting crowded up. There are many more disadvantages also. Now coming to optical fibers. What are optical fibers? It is once again a transparent medium, a narrow strand, we say, very thin structure, maybe lesser than the thickness of your hair. So such a type of transparent medium which makes the light to propagate from one end to another end. Light can, something like flowing water in a pipe, even if it is bent or if it is curved, water can flow very easily. In the same way, light can be made to propagate from one end to another end, even in a curved path. Such a device, we call it as optical fiber. So optical fiber are the devices that effectively conduct light along any curved path. So here we have a simple structure, somebody is holding a thin wire-like structure, wherein which there is a source at one point and there is a glow at the tip of the string or the fiber at the other end. It is only because the light is propagated through this thin structure, which is known as an optical fiber. So in order to understand optical fiber, we have to think of a solid medium. The light is made incident on the solid medium. It gets refracted. That means there is a change in the medium. When light travels from one medium to another medium, it bends, it changes its path. Such a type of phenomenon, we call it as refraction. And in case of glass slab, refraction surfaces. Let me say this is the first surface, first plane. Refraction takes place at this point, and once again one more refraction takes place, and there we find the initial direction of the wave and the final direction of the wave, light waves, they are not one and the same. We say there is a lateral shift. Let us not bother much about this, but we have a condition. Now think of the light being transmitted from denser medium to rarer medium. Denser medium is refractive index of the medium, sin I by sin R. It is constant, we call it as a refractive index. So one medium is denser, the other medium is rarer. We can say glass is denser than air, or glass is denser than water, water is denser than air, or air is denser than vacuum. So one is heavier, the other one is lighter in respect of the refractive index. And therefore, let us say there is a medium in which light travels from denser medium to a rarer medium. So let me consider one ray which is made incident on the surface. It gets refracted. That means there is a change in the direction. There is another wave. It is further the angle of incidence. Here we say there is an angle of incidence being increased. As the angle of incidence is increased, the angle of refraction also gets increased. A stage will come where for an incident ray, the refracted ray will not be in the second medium. On the other hand, it will be grazing through the surface. That is, the refracted ray will be along the medium. In other words, the interface between the two media. It will be neither in the rarer medium nor in the denser medium. It will be exactly in between that. Such a type of process, we call it as, or whenever this happens, we call this angle of incidence as critical angle. So what is a critical angle? If it is the angle of incidence, first thing is the ray has to travel from denser medium to rarer medium. And for a particular angle of incidence, the angle of refraction, here we say angle of refraction is 90 degrees. Angle of incidence, there is some angle of incidence. For glass, it is around 42 degrees. So the angle of refraction is 90 degrees. So this particular angle of incidence is known as critical angle. So think of a medium. Light is incident at this point. It is incident. The refracted ray grazes through the surface. This is angle of incidence. Angle of refraction is equal to 90 degree. So this is a particular case. We can say it is a critical situation. If the angle of incidence is further increased, let us see what is happening there. When the angle of incidence is further increased, the light will not be refracted. Instead, it will be reflected back into the medium. This is called total internal reflection. So total internal reflection, there are two important aspects to be remembered. The light ray has to travel from denser to rarer medium. First one, it has to travel from denser to rarer medium. And the angle of incidence, if it is greater than the critical angle, then only the light will be reflected back into the medium. So such a phenomenon is known as total internal reflection. Total internal reflection. And this is the principle used in your optical fiber. So what happens in optical fiber? If you think of an optical fiber having certain thickness, let us say this is an optical fiber. It is covered by another material. This is first type of material and this is second type of material. Both are transparent medium. When light is made incident here, If the angle of incidence is greater than the critical angle, it will be reflected back into this medium. Again, if the angle of incidence is greater than the critical angle, it will be reflected back into the medium. It is called the total internal reflection. And this is what happens in case of an optical fiber. And in the same way, multiple reflections takes place at several points, and thereby whatever the light that is sent at one point, it can travel miles together and reach the other end without much loss. That is the principle used in optical fiber. Optical fiber is constructed based on the principle of total internal reflection. It consists of a long strand, a thin material, which is a transparent medium. It may be a pure glass, a fine glass without much impurities, or it may be a special type of plastics, or it may be quartz. So whenever light is passed through this material, quartz or plastics, not all plastics, colored plastics are not transparent. It should be perfectly transparent substance. Light has to propagate through a medium. It is nothing but a medium, the substance which allows the light to pass through. So such a type of medium, we call it as transparent medium. So glass is a transparent medium, quartz is a transparent medium, and even some fine plastics are also transparent medium. Main purpose of using plastic is nothing but the flexibility in it. So it can be it is flexible, it can be bent in any shape, any design, whatever it is. And it is known as core. The central portion, we call it as core. And above that core, we have a cover, which is the process of covering this core with the help of another transparent material. We call it as cladding. So cladding means there is a thin core, thin strand of transparent material. On top of that, I can give you a simple example of your pencil. So central, we have that graphite. Over that, it is a wooden piece. Both are not transparent. I'm just giving an example, just a comparison. And in the same way, there will be a thin transparent material which is bounded or surrounded by another transparent material of lower refractive index. Not any refractive index. Refractive index of the core should be higher than the refractive index of the cladding material. And above all, there will be one more core or one more covering just for protection. Something like you're using your anti-scratch screen on your mobile just to protect the screen. In the same way, there will be some synthetic materials or polythenes or plastics that will be coated over it, thereby the inner structure can be protected properly. So application of optical fibers, it is used in digital communication, mainly in computers. It is used in spectroscopy, study of light. It is used in endoscopy, which is nothing but a special diagnosis wherein which without cutting open your internal or cutting open your body to see the internal organs, if there is any ulcer or anything, they will send a wire which consists of a bundle, something like a broom, whatever we find at our home, parquet. So something like that, we have a bundle of optical fibers closely packed, and light will be sent through them, and at the same time reflected, it will fall on certain object, and the image can be caught with the help of some receivers, and thereby it can be connected to the computer monitor and other things, and whatever is happening inside the body can be studied or diagnosed very easily. That is what we call it as spectroscopy. Sorry, endoscopy. It is used in the measurement of low temperatures because light has got some effect on temperature also. It is used in the measurement of temperature. And in some cases, we find some displays, laser lights in some park and other things. We may find some sort of illuminations which are created, which will be called as a light display, and it is known as light shows. And this is a simple diagram wherein which you can understand. We may not have a single strand because it will be very thin. Instead, we have a bundle. Thereby, the safety and the strength can be increased. Not only that, many waves can be propagated at the same time. And that is why these optical fibers, they are mainly used. Thereby, we will not hear the sound. All the routes that are being dialed are busy. Because once upon a time. But now we get plenty of information because many students as well as many citizens of India, they are using this mobile, and all such mobile has to be used simultaneously. Thereby, channel has to be made for so many communication, and sometimes we use this optical fibers. Thank you. I hope this was